you're going to be asked to find equations of lines that are parallel and perpendicular. So I'm going to do a very quick review of what it means for lines to be parallel and perpendicular. So in this example, we can see that these two lines are parallel, these two red lines. And if we were to find the rise over the run, in other words, if we find the slope of these two lines, we'll see we're going up 1 over 2. So this slope is 1 over 2. And down below, it looks like we're going up 1 over 2. So the slopes of both of these lines are equal. And that is important. And that's what is going to determine whether or not two lines are parallel. So lines are parallel if, well, first of all, they're parallel if, as we just saw here, their slopes are equal. Their slopes are equal. Now, just their slopes being equal is not enough. It's not enough because, I can real quick down here draw that line, and I can draw another line that has that same slope. And in that case, it's the same slope and the same y-intercept. But these are not parallel. Yes, they have the same slope. They also have the same y-intercept, and that's not good. Because if they're the same slope and the same y-intercept, then that means they're the exact same line. And we know that parallel lines are not allowed to intersect. So lines are parallel if their slopes are equal, and, so we should put a big and here, and their y-intercepts are different. I'm going to abbreviate it. Their y-intercepts are different. So that's how we determine whether or not two lines are parallel. Perpendicular lines are lines that meet at a 90-degree angle. You can think of the corners of a rectangle or a square. Those edges of that square or rectangle, they meet at a 90-degree angle. And if you think about the corner of a classroom or corner of a room in your house, the wall and the floor, unless you have some sort of strange room, they should meet at a 90-degree angle. So we can determine how these lines are related to each other when we put them on a rectangular coordinate system, combining the geometry of lines with algebra. We can numerically describe these lines. And the thing with parallel lines is that they had the same slope, and that was pretty obvious once we put them on the coordinate system. It was pretty obvious that they had the same slope. It's not as obvious here. We can see, the only thing we can really deduce just looking at this is this line is positive. This has a positive slope, and this line has a negative slope. So if they're perpendicular, they have to be going in different directions. We can see that one's going to be positive, one's going to be negative. So if I just real quick, and these lines aren't perfect, I couldn't get them to be very precise, but we can figure out the slope of this line here. This is going to be a positive 2 over 1, and the slope of, let's see, this line is going to be down to, whoops, let me erase that. I'm going to start somewhere else. Let's start right here. It looks like we're going down 1 and over 2. So the slope of this line is minus 1 over 2. We see that, again, that these lines aren't perfect, but if they are going to be perpendicular, that one of them is going to be positive, one of them is going to be negative, and the relationship between the lines, the relationship between the numbers, is that they're not just opposites, but opposite reciprocals. So lines are perpendicular if their slopes are opposite reciprocals. That word, opposite reciprocal, well, opposite just means one of them is positive, one of them is negative, and reciprocal tells us about the numerator and denominator. So for an example here, we see that 2 over 1 and negative 1/2 are opposite reciprocals. If I had 3 halves as one line, the opposite reciprocal of that, well, this one's positive, so this would have to be negative. We flip the numerator and denominator, negative 2/3. That's what it means to be opposite reciprocals. In this case, we don't care what their y-intercepts are. They could have the same y-intercept, because if they have the same y-intercept and the opposite reciprocal slopes, they're not going to be the same line. And that's what we saw with parallel lines. If they had the same slope and same y-intercept, they were the same line. That's not the case here. So they can have the same y-intercept. Now let's solve an equation where we need to look or find a slope given the certain information about a parallel or perpendicular line.